trying to write sine x plus 2 cos x as r sine x plus alpha. I think this is sometimes known as harmonic series or something. I'd normally call it, just writing it as a single trig function. No, not both of them. This has many advantages, which we'll see later on. We're working in radians. That's one thing to note. R is greater than 0. We're asked to find the exact value of r and the value of alpha to 3 decimal places. Well, here's a little bit of preparation I've done. We need to use addition formulae here, and it's going to be the positive one. So I can write down that r sine x plus alpha is equal to r sine x cos alpha. I'm just replacing a by x and b by alpha and timesing through by r, plus r cos x sine alpha. So what I can then do, this is actually a 1 sine x, I should add, is I can compare them and see that they're very, very similar. I've got a sine x and I've got a sine x. So I can set r cos alpha equal to 1. And then I've got a cos x here and a cos x here. So I can set r sine alpha equal to 2. There's different ways of solving the equations from here. I didn't used to this, but I have become a bit of a fan of it now. I think drawing a triangle is really good, a right-angled triangle, because we're told that alpha is less than 90 degrees. Let's put alpha here. Then I can rearrange the first equation. So cos alpha is 1 over r. I can label the adjacent as 1 and the hypotenuse as r. I can do similar for the sine one. So sine alpha is 2 over r. That means the opposite is going to be 2. And straight away we see we can just use Pythagoras' theorem to get r. R is going to be 2 squared plus 1 squared square rooted, which becomes root 5. You can alternatively just square and add them because you get r squared in brackets, sine squared plus cos squared is root 5, and the sine squared plus cos squared is just 1. But it comes naturally from this triangle as well. And what also works nicely is that now we can say that tan alpha is going to be 2 over 1, or 2. You can also get that by dividing these. You can do the bottom one divided by the top one. So sine alpha over cos alpha is 2, which becomes tan alpha. So it's up to you really, but you just need to find a way that works and that you remember. So, okay, we're in radians. Remember, inverse tan of 2 is 1.1071. Which I'm going to round to 1.11, 3 decimal places. I'm also just going to add that it's equal to root 5 sine x plus 1.11. Although I might keep the full version, because if we do any subsequent calculations, really we should use the non-rounded versions. So on with this question, it's given that the temperature is modeled by this equation. T is between 0 and 24. It's the number of hours after midnight. Using the equation of the model and your answer to part A, deduce the maximum temperature of the room during this day. So we've just shown that this is true. And there's a lot of similarities. Okay, there's another 5, right? We'll deal with that. But this bit here is basically the same as this, except x has been replaced by pi t over 12 minus 3. So I can just replace it by root 5 sine, and then this is now my x. And then using part A, I'm just replacing all of my x's by this pi t over 12 minus 3. So I'll get 5 plus root 5 sine, then pi t over 12 minus 3, plus this 1.1071. Don't forget about that. Now to deduce the maximum temperature of the room during the day, this is where this really comes into its own, writing the function like this, because sine, it doesn't matter what you got inside the bracket, sine is always going to be between -1 and 1. And therefore, the maximum value is going to be theta equals 5 plus the maximum value of this function, which is going to be root 5 times 1. So 5 plus root 5. We're dealing with a modeling question, so this is when we should just give our answer, not exactly, but to say three significant figures. So 7.236 or 7.24, and then degrees Celsius. Finally asked to find the time of the day when this maximum temperature occurs, giving our answer to the nearest minutes. So the sine graph, the normal sine graph, hits a maximum at pi over 2. You've got to be a bit careful here because there's we're doing a scale factor and minusing it from 3. So there are other places where it hits a maximum. But let's just see what happens if we go with it. So sine hits a maximum at pi over 2, which means that would mean that the function becomes 1. And therefore we're going to solve pi t over 12 minus 3 plus 1.1071 equaling pi over 2. That's what is required for the function to become 5 plus root 5. So I've got pi over 2. I can minus 1.1071, add 3, times by 12 to give me pi t, then divide by pi. You can show more working if you want, but I don't think we'll get any more credit for it. So 13.230. Now, that's not the only place where it hits the maximum, but if I did it at the next one along, which should be pi over 2 plus 2 pi, so 5 pi over 2, then t is going to definitely end up being bigger here. It's going to be like the next day or something, because I'm adding 3 on. The only question is, could it be the one before? That's going to be at minus 3 pi over 2, which is going to end up being bigger than, sorry, it's, when I add 3 on, it will still be negative, and you can check that out. So I can ignore that one and ignore that one. It is definitely this pi over 2, but it is something worth being aware of. Okay, finally, we're very close, but it's asked us actually not just for this, but for the time of day, giving our answer to the nearest minute. So this is 13.23 hours after midnight. I can minus the 13 to get the number, well, this is the fraction of the hour that's after 13 hours. If I times by 60, then that will convert it into minutes. So 13 hours and 13.82 minutes. But remember, the time was midnight, which would have been 0000, and then I'm adding these 13 hours and 13.82 minutes. So that's actually going to take me to 1:14 in the afternoon, or 1:14 p.m.